So far we've looked at motors with generally poor to fairly good starting torque characteristics. Where a much better starting torque is required, then a single-phase repulsion start motor is fitted. A single-phase repulsion start motor has a rather different appearance to the motors that we've looked at so far, looking perhaps more like a series commutator motor. We can see that it has a single-phase wound stator and a commutator-type wound rotor, with the brushes shorted out by this heavy conductor. Not only does it look different, but during starting it works on a rather different principle. This diagram shows the principle of operation during starting. When the motor is switched on, induction between the stator and the rotor windings causes current to flow in the rotor and the short-circuited connections. Here the brush axis is in line with the axis of the stator winding. We can see that at any instant the polarity produced in the rotor is directly opposed to the stator polarity, and so there is no force to create rotation. The brushes have been moved 20 degrees around the commutator, and now, because the axes are no longer in line, repulsion takes place. With this type of motor, once the shaft is up to speed, a centrifugal device short-circuits all of the commutator segments and also lifts the brushes from the commutator. In this way, the motor is converted into the equivalent of a cage induction motor and has similar characteristics. The last type of induction motor we shall look at is much smaller and works in a rather different way. It's the single-phase synchronous or shaded pole motor. This small motor has a squirrel cage rotor and a stator with special slots into which copper rings are fitted, similar to an AC contactor. The primary flux cuts these rings, inducing an EMF which causes current flow around them, and therefore a secondary flux. The combination of these fluxes produces a form of rotating field which cuts the rotor bars and causes rotation. And this is from the unshaded to the shaded portion of the poles. These motors are cheap and reliable, and although they have a poor starting torque and a low efficiency, usually in the region of between 20 and 30%, they are widely used for very small fans and pumps. The last single-phase motor we will look at today is not an induction motor, but is in fact a series commutator motor, often called the universal motor because it will operate on either direct or alternating current supplies. In common with DC motors, it has field coils, a wound armature with a commutator, and has the same characteristics as a series DC motor. That is, it tends to race when it's not loaded, as we can hear. These motors are widely used in portable tools and equipment such as vacuum cleaners. Well, that's about it. We've looked at the theory behind the induction motor and something of how they're built. Single and three-phased cage rotor motors, wound rotor motors, shaded pole motors, and finally the universal motor. Our next video in this series looks at electrical installation faults and fault finding. See you soon.